All right, so this is the mid-module 2 study guide number 8. Use the diagram below to answer the following questions. The first part says, state the pair of similar triangles. Which similarity criterion guarantees their similarity? And then calculate DE to the hundredths place. Okay, so let's first think of what are the 3 ways that 2 triangles could be similar. What are the 3 ways that 2 triangles could be similar? Can you see the question that we're on, Gracie? Are you on the right slide? You see it? You're welcome. So the 3 ways that 2 triangles can be similar is if you know that you have 2 congruent angles. This is from the mid-module 2 study guide, and then this is number 8. You could have 2 angles, or you could have 1 angle and 2 proportional sides, or 3 proportional sides. All right, so let's look in our diagram and see if we can figure out any of that information. Okay, so are there any congruent angles? I always like to start there because that's just easier to me. Are there any, you see the 2 triangles that we have here in the diagram? We've got triangle DEF and GHF. So are there any congruent angles that those 2 triangles have? Okay, why do you think G and E are congruent? Is there a reason? Are we told they're congruent? We actually don't know, right? They might be, but we can't rely on anything to be drawn to scale. Just that the locations are drawn correctly. So we don't know if G and E are congruent. Try again. There is actually at least 1 angle pair that is congruent. Do you see? No, we're not sure about H and F. Well, we can technically, yes, be sure that H and F are not equal, because if they were, that would make GHF an isosceles, and that would mean that GH would be the same length as GF, but they're not, so that means H is not congruent to F. Actually, out of the 2 triangles, they both share the angle F, right? The measure of angle F is equal to the measure of angle F because of the reflexive property of equality. Everything is just equal to itself. And both of those triangles have the angle F in there. Is that okay so far? Cool. So we have met at least 1 part of the angle-angle criteria requirement and at least 1 part of the side-angle-side criteria, requirements. And then we haven't met any requirements for the side-side-side. So let's see if we can find another angle, then we'll be done, or we'll have to look at some sides. I don't see any more angle information, but I do see some side information. Can we check to see if 2 pairs of sides are proportional? So let's think about this. For the big triangle, okay, DEF, how many sides of the yellow triangle do I have lengths for? 1 side, 2 sides, or 3 sides? So for triangle DEF, do we have a length for DE? Do we know what the length of DE is? How long is DE? Is that given to us in the diagram? It's not, right? So I can't use that one. What about DF? How long is DF? Very good. So do you see where that comes from, Gracie? If D to G is 11 and G to F is 6, then from D all the way down to F is 11 plus 6, which is 17. And then what about the third side of our big yellow triangle, EF? How long is that side? Very good. Yeah, don't overthink it. We're just adding them together. So E to H is 4.75. H to F is 8. So we'll just add those two numbers together. 4.75 plus 8 is just 12.75. All right, so those are the two side lengths that we have for the big yellow triangle, right? Is that okay? So this is all for triangle DEF. So now let's see if we can identify the sides lengths for triangle GHF. And I haven't written these in any particular order so far. Okay. So let's see, what is the length of GF? Just pull that right from the diagram. What's the length of GF? It's just 6. Very good. What's the length of FH? Just pull it right from the diagram. Is 8. And then GH, the last side of the little triangle. Let me highlight it so we can see, what we're talking about here. The little triangle we'll do in pink. Like that. So yeah, so GH is 4.25. Alrighty then. So, if we're going to use, we know we can't find another angle, and we can't use side, side, side because I don't have the third side of the yellow triangle. So that means I'm probably going to have to use side, angle, side, okay? So if the angle that they share is F, then the sides that need to be proportional are on either side of that angle, okay? So the sides that are on either side of the angle for the yellow triangle are the only two that we have, the 17 and the 12.75. So I'm going to write those in a fraction together. Well, that's what we're trying to do to see if side, angle, side can work for us. Then, what are the two sides for the pink triangle that are on either side of the angle that they share? Which two numbers or the names of them? 8 and 6. Very good. So that's GF and FH. Okay, so what we did when we were setting these proportions up, we have to make sure that we have the correct sides paired together. So we have to make sure that when it's going to be proportional, they have to go together bigger to smaller. So what I did for the yellow triangle DEF was I wrote the bigger side in the numerator, right? See that? I put 17 in the numerator. So that means that for triangle GHF, in order to test to see if they are proportional, I have to also write the bigger side in the numerator. So what should I put in the numerator for triangle GHF? 8. Yeah, 8 over 6. So now, a couple of ways we can do this. We can cross multiply and see if we get the same number, or we can divide both of these fractions and see if we get the same number. So 17 divided by 12.75 gives us 1.3 repeating. And 8 divided by 6 also gives us 1.3 repeating. So are those sides proportional? Yes, because this is true. That means they are proportional. The two sides are. And since we already established the angle, that means that the two triangles are similar by side, angle, side. Two proportional sides, one congruent included angle. So then we also have to, it says to state the pair of similar triangles. That means we have to write the similarity statement. So if I start with triangle DEF, it is similar to what triangle? We want to make sure that we have all the vertices lined up correctly. Okay, so you want to try GHF? So let's take a look. So what angle do they have that's congruent? It is angle F. And so those are both in the third position. So that's very good. Yes, that part is correct so far. Let's check DE and GH. So the 17 came from side DF, right? And the 12.75 came from the side EF. The 8 came from the side HF, while the 6 came from the side GF. So we have to make sure that D is lined up with H and that E is lined up with G. Is that happening in our similarity statement? Aha, it's not. So how can I fix this? What should my second triangle be called instead? Yeah. So the orientation is just a little bit different. Oh my. Not what I wanted to happen. Okay, hold on. Let me group this as background. Well, whatever. I'll just rewrite the whole thing. Yes, HGF. So there we go. Ta-da! All right, how are we doing on part A? Green check if you're good, red X if not. What about you, Gracie? Is that okay so far? Are you still here? Okay, so then part B says to find the length of DE to the hundredths place. Sorry, I got it covered up now. But DE is going to correspond with that 4.25, right? So DE corresponds with 4.25. So we just need to set that equal to another pair of corresponding sides. So we can see that when we did our proportion over here, 17 from the big triangle corresponds with the 8 from the little triangle. DF corresponds with HF. So now I can just cross multiply and solve. So 8 times DE is equal to 17 times 4.25, which is 72.25. Then we'll divide by 8. So DE is equal to 9.03 rounded to the nearest hundredths. Yay! All right, how's that? Is that okay? Green check if yes, red X if no.